Hello everyone, it's Daniel. I present my paper about 3D printing from Germany via this video. And I hope you can hear me loud and clear now. The first experiences with 3D printing I had during research work for my home university in Germany. And here at NCTU I also took the additive manufacturing course, where I gained all the technological background for this topic and where we actually printed our own physical models in group projects. My motivation to choose 3D printing for this paper is because it has possible applications everywhere, from shoes over sports articles to highly complex and functional medical parts. And as you can see in this figure from 2012, it has great future opportunities as an evolving market. But we will talk more about the market and its figures later. First, I want to start to explain the technology. The supercategory of all 3D printing technologies today is determined to be called additive manufacturing, which implies the layer-based manufacturing process. And in the upper part, you can see a 3D CAD model, which is digitally sliced to layers with a finite thickness, and afterwards printed layer upon layer in a simple extrusion process. In the lower part, you can see an advanced industrial powder-based technology, so-called selective laser melting. Here a laser is melting the top layer of the powder according to the actual cross-section of the CAD model for this layer. And after the laser has finished one cross-section, the powder bed is lowered according to the height of one layer, and the recoater plate is dispensing a fresh new layer of metal powder. On the left side you can see the comparatively simple and cheap fused deposition modeling technology, which is commonly used for domestic printing applications. The build materials are plastic threads provided on spools, and these spools feed the extrusion nozzle, which heats up the plastic and deposits it in XY direction on the current layer. After one layer is finished, the build platform gets lowered according to the height of one layer. On the right side you see the first patented AM technology from the year 1984. It's the so-called stereolithography, where a UV laser is hardening a light-sensitive liquid resin in a tank layer by layer. The latest technology, which entered the market in April 2016, is the so-called continuous liquid interface production, which kind of reminds me on a futuristic scene from Terminator 2. Here the UV light is projected from the bottom of the tank as full cross-sectional images, while the build part is constantly moved upwards. And the continuous build process leads to a faster process with smoother surfaces. But I explain this and a couple of other interesting technologies more detailed in my paper. The applications for AM technologies are broadly spread. It ranges from spare parts and customized parts in the aerospace industry to functional or visual models in the automotive industry. And other big applications for 3D printing are for demonstration issues in educational institutions or to generate artistic items. At the moment, there is no established market for additive manufacturing technologies. The development is still challenged to keep up with the rapid evolvement of the materials and the technologies. The drivers for the market evolvement are that we have no limitations of design in contrast to traditional manufacturing methodologies, And we have mass customization and reduced lead time because we can simply adjust the virtual model and reprint it instead of creating a new mold first like in traditional technologies, which can take weeks. And we don't need additional tools, or we can just print new tools if we want. And also we don't need stocks anymore for spare parts because we can just print them on demand from the virtual file. And finally, the biggest market driver in the low-end sector is that after 30 years of the first patent, we have a lot of patents expiring, which leads to a more competitive market and an explosion for low-end solutions. In my paper, I further did a SWOT analysis. The strengths are mostly covered with the market drivers from the previous slide. And the first weakness of the additive manufacturing technology is that it is a rather new technology, which means that it suffers from a lack of standards in technology and materials. Further on, some of the technologies still have accuracy and repeatability problems. However, one of the opportunities is the outstanding research effort in material science and engineering to expedite the improvement of those technologies. And another opportunity is the combination with traditional manufacturing methods in hybrid processes. And a completely new business model opportunity can be found in the production by demand on location. Threats for the 3D printing technologies are that we also face superb advances in virtual reality systems, which make physical 3D models redundant and maybe unnecessary in the future. And for the manufacturing, we also have advancements in competitive traditional technologies like CNC machining. As promised, I have some more figures for the market with thanks to statista.com. The total number of 3D printers sold more than doubled from 2015 to 2016 from around 200,000 to almost 500,000 printers. And the estimation for units sold is rapidly growing to 6.7 million units totally sold in the year 2020, which means that the number almost doubles every year. For the whole market of additive manufacturing, comprising the technology, software, material and services, we have a market size of $15.9 billion worldwide in 2016, which is estimated to be growing with a CAGR of more than 20% to $35 billion in 2020. I hope that my presentation has demonstrated the advancing technology behind additive manufacturing and its evolving market situation. Combined with the fact of the expiring patents and the complexity of the system, I think that we face the optimal conditions for an extremely competitive market in the future. Thank you for your attention and enjoy the rest of the presentations.